This is the solution for the review mock exam for exponentials. You can use your calculator for the exponentials mock exam and for the actual exam. So a group of 10 leopards is introduced into a game park. After 2 years, the number of leopards n is modeled by n equals 10 to 10 times e to the 0.4 t. So this is just, they gave you the equation, so we definitely want to put it in the calculator because we can use the calculator to solve these. Now, be careful when you put the equation in the calculator that you put parentheses where you need to. That would be here, for example. 0.4t, and you would use the x here. Okay. So we have the equation in the calculator, and we want to find out how many leopards will there be in 2 years, and x is the number of years, or t is the number of years. So we just need to make a table, and okay, let's go to x equals 0. So x equals 0 is 10. Does that make sense? Yes. So the first, the initial value at 0 years is 10. And then the value, the number of leopards after 2 years would be 22.255. Now, since it's leopards, doesn't make sense to put 22.255 leopards, so you would either round up or round down. In this case, I don't. You could justify rounding up by saying, yeah, well, there's no 0.255 leopards, so that would be 1 leopard. Or you could say you're rounding numbers below 0.5 down. So you could put 22, you could put 23. Either one of those would be acceptable. Okay, how long will it take for the number of leopards to reach 100? Give your answers to an appropriate degree of accuracy. I'm going to show you 2 ways to do this. One of them is using a very rough degree of accuracy, which is, oh, they asked me the number of years, so I'm going to tell them the number of years. So let's see when it gets to 100. Oops, so we already went way past 100. So it looks like it reaches 100 somewhere between 5 and 6 years. So we might say, 6 years, less than 6 years. But we could be more accurate than that. Now, how could we do that? Well, one of the ways you could do it is you could get another significant figure by putting plus and 0.1. And then now we have, let's see, we could get it to 5.8, right? 5.8 years. So that's a little bit more accurate. And then if you wanted to, you could do plus 0.01. And then you could get even closer. Oh, look at that. So it actually reaches 100 at 5.76. Okay. And then I'm going to show you the final way to get an even more accurate number. What you do is you graph it. Okay, and that's not a very good view of it. Let's do zoom fit, or zoom standard, so that we can see the middle of it here. And so we can see the graph right there. That's probably not also enough because we actually want to see the right side of this graph. So let's adjust the window size so that its x max would be maybe 20 and y max would be maybe, let's see, it's going up to 100, right? So let's put 150. Now we graph it. Okay, and let's say we want to know exact when this curve actually becomes exactly 100. To figure that out, we go down here and we put y equals 100 as another function, and we graph both functions, and we can see that the line y equals 100 is exactly at the level that we want to know what the x value is. And to find that out, we can use the second calc intersect function to find exactly the coordinate of intersection. So let's do that. Second calc intersect. And then you say first curve, yeah, the exponential. Second curve, yeah, the y equals 100. And then it says guess, and there's only one intersection, so we'll just go ahead and do enter. And the intersection is 5.756. And see, we got one more significant figure doing this. Okay, so 5.756 comma 100 is the coordinate. So we could say, 5.756 years. We could say 5.76 years. We probably cannot get away with just saying 6 years in this case. Okay, so that's how you get more digits. Next problem is a exponential that is going down, and we can tell it's going down because of the negative exponent. Okay, so again, we definitely want to put this in the calculator. So let's put it in the calculator. It has, a machine was purchased for $10,000. After 2 years, the value is given by $100,000, and that's interesting. That's interesting. I think there's a misprint here, and I'll fix this on your test. So instead of 10,000, we want this to be, or instead of 100,000 here, we want it to be 10,000, right? And then we'll put e to the negative 0.3t. And you can see that since this is in the exponent here, there's no danger of really needing parentheses or not, but we could put parentheses just to make sure. Negative 0.3x instead of t. And then clear that. And we're going to graph it. Find the machine must be replaced at the end of the year in which its value drops below 1,500. So determine how many years it needs to be replaced. Do you see how they're asking at the end of the year? So if they ask at the end of the year, then you don't have to give fractions of years anymore. But we do not want to jump by 0.01, otherwise we're never going to be able to get through this table. So we're going to do second table set, change the table start to 0, change the delta table to 1, and then we'll try again, second graph table. Okay, so it starts at 10,000 and then it starts going down. When does it drop below 1,500? Drops below 1,500 at between the 6th and the 7th year. So in 7 years, you're going to need to replace it, right? Now, if you wanted to figure out the exact value here, you would do what you did last time. So you would take the y equals, and you would put y equals, and you'd put 1,500 here. And then you'd graph it. And we probably need to adjust the window so that we can see this graph, because 1,500 is very high. This is probably goes up only like 20 or 30. So let's take a look at the window and change the y max to something very large. Oh, it goes up to actually 150, but we put in a value of 1,500, so we need to put at least something like 2,000 in here. Graph. Okay, let's find the intersection of that point, and that will give us the x value, which makes the y value exactly 1,500. So we go second calc, intersect, and then first curve is the exponent Yes. Second curve is y equals 1500. Yes. Guess. It doesn't matter what you put because there's only one intersection. And the intersection is 6.3237, etc. Y equals 1500. So if we wanted to give an exact answer, in this case you don't because it says replaced at the end of the year, you could put 6.324 or 6.32 years. Okay? And just as a reminder, if they ask for months or something, you could take the fractional part of this. It would be 6 years and how many months? Well, to figure out the number of months, you could multiply 0.324 times the number of months in a year, which is 12, right? 12 months, and then that would give you 12 times 0.324. It would give you about almost 4 months, right? 3.88 months, okay? So the answer to this, though, would be 7 years. I was just showing you how to do the intersection because if they ever ask you exactly, you'll need to do that.